Okay, so hello all. Today we are going to deal with one program that deals with to find the addition of first 10 integer numbers, right? So this is an assembly level language program to find out the addition of first 10 integer numbers. Okay, so again, as usual, we have discussed first starts with area. Okay, and then we are keeping the name of the program as sum1, then code and read only. Okay, then we are exporting it so as to the assembly level language can get converted into main program. Okay, and then starts with main. So whenever we are having the addition of first 10 integer numbers, we should make sure that we should have a counter first. Okay, we should make sure that we should have a counter. Okay, how much of 10 numbers? Okay, so we should initialize a counter of 10 numbers so that it can count, for those many numbers. Okay, so when we are doing this, what is the next step? The next step is we should initialize one more register as 0. We should initialize one more register as 0. So here the output gets stored. The output gets stored. Correct? The output gets stored. So when we have initialized one counter and second one we have initialized one register to store the output. Next one, what is that? We have to go add. We should start adding it, right? So add R2 is equal to R2 plus R1. Okay. So what is that? R2 is equal to how much now? R2 plus R1, right? So what is R2? R2 is 0. R2 is 0, 0 plus is how much? R1. R1 is what? 10. So what is the output? It will be 10 only. Correct? So now how much the value of R2 now? The value of R2 is 10. When this instruction gets executed, that is add as gets executed, becomes 10. So when we have done this, now what? We should decrease the counter. We should decrease the counter. So we will utilize one more instruction called as subbase. Okay, we will initialize one more instruction called as subbase. So what is that subbase? Subbase nothing but subtract. Okay, where R1 is equal to this one. So what this instruction will do? R1 is equal to R1 minus 1. Correct? So R1 is how much? R1 was first 10 minus 1. Now how much it is? It is going to become 9. Correct? So what is the value of R1 now? The value of R1 is now, okay, the value of R1 is now 9. The value of R1 is what? The value of R1 is now 9. Okay. But we have to do this for how many times? We have to do it for 10 times. So then we are going to utilize an instruction called as BNE, branch if not equal. Branch if not equal. That is what is BNE stands for. Okay. So here we can utilize one more instruction. That instruction is nothing but what? Okay. Here we can use one more instruction. That instruction can be CMP compare. Okay. Compare what we want to compare. You need to compare R1. Okay. With hash of 0, 0. Okay, compare R1 with 0, 0. That means what? You are going to compare R1 with 0, 0. Okay, that means what? You are checking whether the counter has ended up or not. Okay, when you are done this, then you are supposed to use an instruction called as branch if not equal. That is nothing but BNE instruction. That is nothing but what? BNE instruction, branch if not equal. This instruction, what it does? This instruction will check whether R1 is 0 or not. R1 is 0 or not. Okay, this instruction branch if not equal checks whether R1 is 0 or not. If R1 is not 0, what it will do? It will go to loop. Then it will again come down over here, add as. Okay, now R2 is equal to R2 plus R1. Again the same thing. What is my R2 now? R2 is 10. And what is my R1? R1 is nothing but what? 9. So this instruction will add how much now? This instruction will add 9. Again the second instruction over here, subbase. So what this instruction will do? It will subtract 1 from R1. So first it was 9, now it became 8. So again R1 you are comparing with what? 0 0. So what is the value of R1? R1 is 8. So it is not 0. Again branch if not equal. That means if R1 is not 0 to loop. So where it is will come? It will come down over here. Okay. Again it will come down over here. So what is the value of R2 after the execution of the second round? It is 19. Okay. So what is R1 now? R1 is what? 8 now. So it is going to be 8 now. It is going to be 8 now. Correct? When the second instruction gets executed, sub is R1 with 1. So R1 was 8, now it becomes how much? 7. So now again R1 gets compared with 0. So if it's R1 value is 0, so the 7. So branch if not equal. That means if R1 is not 0, go to loop. So it will come down over here to loop. Okay. So like this process will continue till R1. Okay, till R1 becomes 0. Till R1 becomes 0. So when R1 becomes 0, what will happen? Branch if not equal. Okay, that means if R1 is not equal to 0, then only you should go to where? You should go to loop. If it is 0, then what? You should execute this instruction. That is nothing but label branch to again label. So that means what? The program counter will stay back here only. The program counter will keep on stay back here only. So that it will enter into what? Infinity loop. So that it will enter into what? Infinity loop. Now the point is that what should be the answer? The answer should be 55 in decimal. Answer should be 55 in decimal. Okay, but when you convert it to hexa, you will be getting it as 37. But when you convert it into hexa, you will be getting it as 37. Okay, so you should execute it and then you should see what is the value of R2. Right? Similarly, you can do multiplication operation also. Okay, so it is to the program is that write an assembly level language to find out multiplication of first 10 integer numbers. Right? If you are doing that, instead of add as, what should be the answer? What should be the instruction? It should be MUN. If you do this, what will happen? You will be getting the value of first 10 integer numbers. Okay. But what is the change? The change over here that R2 should not be 0. R2 should be 1. When you are doing multiplication, the value of R2 should be 1. Okay. So this is what we have done for addition and multiplication of first 10 integer numbers for R. Okay. So I suggest you all people, the students, to execute this and see whether the output is correct or not. Even you can do it for subtraction, multiplication, division, everything. What all the arithmetic instructions are there, those instructions you can try it in this programming set. Okay. So thank you for your patience. Okay. Execute and store the answer. Thank you.